last lesson we talked about functions, gave an introduction to what functions are. Now we're going to look at some of the more important functions that come up quite often in calculus. Maybe the simplest is just the function f of x is equal to x, which means whatever number you stick in, you get exactly the same number out. So if you stick in a 1, you get out a 1. If you stick in a 2, you get out a 2. If you stick in a -3, you get out a -3. And if you sketch all those points together, you just get a straight line with, it's called the slope of 1. We're going to talk about lines in the next lesson. But there's the graph of the function. You can use any letter you want to denote a function. Let's let g stand for the function g of x is equal to x squared. How does this differ from x? Well, now for every number you stick in, you're going to square it, and then that's the number that comes out. So you stick in a 3, you'll get out a 9. You stick in a 1, you'll get out a 1. You stick in a 1/2, 1/2 times 1/2 is 1/4. So you sketch all those points, and it looks something like that. If you stick in the negatives, you'll get the same values back out as you would with the positive, because the negative times the negative gives you a positive. So you get a graph that looks like that. It's called a parabola. What happens if we cube the value rather than square it? Well, now you stick in a number 1, you get out a 1, stick in a 1/2. 1/2 times 1/2 times 1/2 is 1/8. So up until you get to 1, these numbers are going to be smaller because you're multiplying a small number by itself 3 times. But once you pass 1, now if you stick in a 2, for example, 2 times 2 times 2 gives you 8. So it actually grows rather fast. So it starts kind of slow, but then ends up growing rather fast, kind of like that. And then what happens if you stick in negative numbers? Well, -2 times -2 times -2 is -8. So it's going to be the same size of number that you had on this side, but it's going to be negative instead. So it looks like that. So notice the difference between x squared and x cubed. What about the square root of x? Well, first of all, notice that it's impossible to take the square root of a negative number. What number times itself will give you a -9? Nothing. So there's no square root of a negative number. The only thing it makes sense to take the square root of is numbers that are 0 or positive. So that the domain of this is everything greater than or equal to 0. You can write it like that, or you can write it like this. Everything greater than or equal to 0. This means you include 0. You're never going to get out to infinity. So what happens when you stick numbers in here? If you stick in a 9, the square root of 9 is 3. The square root of 1 is 1. And if you sketch all those, you're going to get something like that. That's about as nice of a square root as I've ever drawn in my life. So there's the square root of x. What about the cube root of x? Well, let's see. The cube root of 8, what number multiplied by itself 3 times will give you 8? Of course, that's 2. So the cube root of 8 is 2. The cube root of 1 is 1 again. If you take all those and connect them together, you get something like that. But now, notice that it is possible to take the cube root of a negative number. What number times itself 3 times will give you a -8? A -2 will do. And so it is possible to take the cube root of negative numbers. It's going to look something like that. So there's the cube root. And it looks like we have time or space for one more over here. Let's let m of x stand for the absolute value of x. What does that function look like? The absolute value of a number is basically the distance of that number from 0. So if you're at either 1, 2, 3, or 4, the distance of 3 from 0 is 3. On the other hand, if you're at a negative number, the distance of -3 from 0, there you're asking for the distance, which is always a positive quantity. It's also going to be 3. So the definition of the absolute value is it's the same value, same number, as long as that number is greater than or equal to 0. It's the opposite if that number is less than 0. And so if you sketch all those points out, you get something like this. A very interesting and important function in calculus. Okay, we've run out of space on our little 3x4 board, or whatever the dimensions of this are. So let's erase what we've got here to put a couple other ones down. Here's a very important function, and also one that students sometimes have trouble understanding. 1 over x. What does 1 over x look like? Well, if we, again, just plot some points. If you stick in a 1, you get a 1. Stick in a 2, 1 over 2 is 1/2. Stick in a 3, you get 1/3. Stick in a -2, and you're going to get -1/2. Of course, -1 gives you a -1 out, and so on. So those are all no problem. It's more interesting, and students have trouble with it sometimes, when you ask what happens when you stick a 1/3 in there. What is 1 divided by 1/3? You might remember the algebraic technique that if you take 1 divided by 1/3, that's the same as you take this, when you flip it over the line, you have to flip it over itself. So it's 1 divided by 1/3 is the same as 1 times 3 over 1, which is equal to 3. So that's the rule, but does it make sense? Why is that? And the way I like to describe it is this. If you have 8 pizzas and everyone eats 2 pizzas, how many people can you feed? Of course, you can feed 4 people. If you have 12 pizzas and everyone eats, say, 4 pizzas, how many people can you feed? Well, 12 divided by 4 is 3. And similarly, with this thinking in mind, if you have 1 pizza and everyone eats 1/3 of a pizza, how many people can you feed? And of course, you can feed 3 people. So that's, I think, kind of the easiest way to understand why 1 divided by a 1/3 is equal to 3. 1 divided by 1/5 is, of course, equal to 5, and so on. So here the answer is 3. If you had -1/3, it's going to be the negative of this, so it's going to be -3, and so on. So that's most of it. One other thing we need to worry about a little bit, is what happens if we divide by 0. What's 1 divided by 0? Well, let's go back to my 8, 2, and 4 situation. 8 divided by 2 is equal to 4, and the reason that is because 8 is equal to 4 times 2, right? 12 divided by 4 is equal to 3. Why is that? It's because 12 is equal to 3 times 4. Okay? So if I take 1 divided by 0 and set it equal to something, what could I set that equal to so that 1 is equal to that something times 0? What can I multiply by 0 to get 1? And of course the answer is nothing. It just doesn't work at all. That's supposed to be a question mark there. Okay? There's nothing I can take and multiply by 0 to get a 1. So it doesn't make sense to divide by 0 at all. So this function here, the domain of it, is going to be everything except 0. So I can either write that like this, just to say x is not equal to 0, or another way of writing it is it's everything from -infinity to 0, and this little sign, the fancy word for it is union. It just means together with or along with everything from 0 to infinity. And this means the fact that this is a parentheses there indicates that we're not including 0, we're just going right up to 0. So there's the domain. if you were to graph this out, graph all these points, you see that at 1 you get a 1 out, and then as you put in bigger numbers you get smaller numbers out. As you put in smaller numbers here, 1 over them gets to be big number. Oh, that didn't look very good. Let's try that one again. A little bit better, like that. And then here you get something which is similar, but they're all negative instead. So a very important function there. Okay, last one that we're going to look at, which is just again another important one, is g of x is equal to 1 over x squared. Okay, what does that look like? Well, let's see. We could do it similar to this one. Stick in a 1, you get a 1 out. When you stick in a 2 here, 1 over 2 squared is going to be 1/4. Stick in a 3, 1 over 3 squared is going to be 1/9. So it's going to go down just like this one, but it's going to go down faster. It's going to go down faster. It'll never hit 0, but it'll go down pretty fast. On the other hand, if I put in a 1/3 here, then what happens when I put in a 1/3? Can you do this in your mind? 1/3 squared, 1/3 times 1/3 is 1/9. So 1 over 1/9 is 9. So instead of just shooting up to 3, it's going to go all the way up to 9. So this is going to go up very, very quickly and look something like that. If I put in negative numbers, notice that if you take a negative number and square it, you get a positive. So it's going to look the same on this side as it does on the right-hand side. So it looks kind of like a volcano there. It blows up at 0. So there's the graph of 1 over x squared. Okay, so now that we are familiar with those as kind of standard functions, we're going to be using those along with some other ones that we'll be learning about in the lectures coming up. Let's just do 1 or 2 more problems that involve the domain. So how about this as an example? Find the domain of f of x is equal to 1 over x squared minus 5x plus 6. Okay, so recall we can't divide by 0, so the thing we have to worry about is we don't want this thing to be 0. So let's find out when it is 0. When is x squared minus 5x plus 6, when is that equal to 0? And so recall what we learned in the second lesson. If you have an equation like that and you want to find out where it's 0, you first need to factor it. This thing can be factored into x minus 2 times x minus 3. And now recall that if either one of these things is 0, the product will be 0. So you have 2 options here. You have x equals 2. That will make this one 0, or x equals 3, that will make this one 0. So those are the 2 points, values of x which are not allowed. So that you could say here your domain is x not equal to 2 or 3. You can maybe write them like that, just to indicate there's the collection, there's the set of points which x cannot be equal to. Or if you want to, you can write it like this. You can say everything from minus infinity to 2. You can't include 2, but that's together with everything from 2 to 3. And you can't include 3, but then everything bigger than 3 also works. So you can write it like this. The domain is this, together with this, together with this. What happens if we change this function to look like this instead? Now we have to ask the question, when will this be non-negative? Because it doesn't make sense to take the square root of a negative number. So when will that be either positive or 0? So the way to answer that question is to first find out where it's equal to 0. And we already found out it's equal to 0 at 2 and at 3. So we've got that. Now let's go ahead and just think about what this function looks like. What does this function look like? Here we are at 2 and at 3. This thing is equal to 0. We're going to learn about a word called continuity a little bit later on in the course, but essentially, since these are the only two places where it's 0, we can then check all these other intervals and find out where it's either positive or negative. So for example, here's what all you have to do. If I stick in a number bigger than 3, let's choose 4. If I stick in a 4, this is the same as this. If I stick a 4 in here, 4 minus 2 is positive. 4 minus 3 is positive. Positive times positive gives you positive. So anything greater than 3, both of these things will be positive, and positive times positive gives you a positive. So everything the function is positive from 3 on up. If I stick in a value between 2 and 3, like 2.5, 2.5 minus 2 is positive. 2.5 minus 3 is negative. A positive times a negative gives you a negative. So in here, this particular function is negative. In other words, let's check it out. If I stick in any number between 2 and 3, this will be positive, this will be negative. Positive times negative is negative. So that part there cannot be in the domain of this function, because this thing under here would be negative. What if I stick in something to the left of 2? 1's a nice convenient number. If I stick in 1, 1 minus 2 is negative. 1 minus 3 is negative. Negative times negative is positive. So again, this thing right here is going to be positive to the left of 2. If you're left of 2, this is positive, this is positive. Positive times, I'm sorry, this is negative, this is negative. Negative times negative is positive, so you're set there. So the domain of this function would be what? You could either write it as, well, I guess the easiest way to write it is just to say the domain is everything from minus infinity up and including 2. So you put a square bracket there to indicate that you're including 2. And then we don't want anything in here, but that's together with everything from 3 to infinity. So there's the domain of that function. Okay, very good.